Hello, eighth graders. So we're looking at our second assignment for AMI Week 6. This is simplifying square roots. I'm going to introduce this concept to you guys for the first time. So this is something new, so you probably definitely want to go through watching this video. All right. So in the past, we have the last few lessons we've done when you were trying to take the square root of a number, we were just approximating it. So that means we were rounding the number. So we were saying things like it's close to 7, it's in between 8 and 9, things like that. So today I'm going to show you how to simplify a square root in the most exact way possible. That way we don't have to round our answers. So this is a skill that you can use in the future when you're doing things like Pythagorean theorem and anything else that involves you having to take a square root. You'll hopefully after this you'll have a better idea of we want to simplify that. So I'm going to work through the 3 examples. There are 3 on the page, 1, 2, and 3, and then I would like for you guys to do exercises 1 through 4 on your own. So let's go ahead and get into it. Before I start with number 1 though, let's switch us over to my other tab. Now, if you have not already made one of these for yourself to just use as a reference, I'd recommend it. So this is my list of perfect squares 1 through 20. Now, if you want to write what number squared equals them to, I would recommend that if you don't know them already in your head like I do. So for example, you might in your chart replace this as 1 squared equals 1 and go through and write them out that way. I don't do it that way because I already have that part memorized, but because really whenever we're trying to factor, using simplifying square roots like I'm about to teach you how to do, you really just need this number to start off. But wouldn't hurt for you to go ahead and have both. So if you guys want, you guys feel free to email me and I can share this document with you fully filled out if you'd like. That way you can have it and print it out to use. But feel free to just reference it as well. All right, so our perfect squares 1 through 20 are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. So that's the end of the ones that you're probably already familiar with. But after that, we have 13 squared is 169, 14 squared is 196, 15 squared is 225, 16 squared is 256, 17 squared is 289, 18 squared is 324, 19 squared is 361, and 20 squared is 400. So I highly doubt you'll need to use one higher than that in any math you would possibly be asked to do this year and maybe even next year. So this is a pretty good resource for you. All right, so I'm going to use these numbers in the lesson, so I just wanted to make sure you understood what I was referring to when I say perfect squares. It's a number squared equals this, a number squared equals this. These are the answers to that, 1 through 20. All right, let's go back to the lesson. I'm going to be switching back and forth probably quite a bit between the tabs in this lesson. So example 1, simplify the square root as much as possible. So if I want to try to simplify a square root, the first thing I want to ask myself is, can I take the square root of this number and it come out even? If it does not come out even, then I'm going to have to try to factor it, which this is something you haven't tried to do before. Now, you've factored before, but maybe not tried to search for specific factors for something like this. So, what I have here, when I take the square root of 50, that is going to give me about 7.07. So it doesn't come out as a whole number. Therefore, I need to try to simplify it using other means. That way I'm not giving an approximate answer. So what I'm going to do is I am going to try to find a perfect square that is a factor of 50. Remember that when I talk about factors, that means it's numbers I can multiply to make 50. So 1 times 50 is 50. Those are considered factors. 2 times 25 that equals 50, those two numbers are also considered factors of 50. So what you want to do is you want to go through your perfect squares and you want to ask yourself, are any of these factors of 50? So as I'm going down the list, 1 is obviously a factor of all of them, so we don't count 1. I cannot divide 50 by 4 evenly. That would not work. I cannot divide 50 by 9. That would not work either. I cannot divide 50 by 16. But I can divide 50 by 25. That will work because 2 times 25 equals 50. So those are factors. So what I can do with my square root of 50 is I can change the number inside of the root by factoring it. I can say that the square root of 50 is also equal to the square root of 25 times 2. Do we agree that these are both true? 50 is equal to 25 times 2, so these will both be equal. Now, once we have factored out our original number to a square or a perfect square times another factor, then what I'm going to do is I will try to take the square root of each number that I can, but I'll only take a number out if it comes out evenly. So when I take the square root of 25, that is going to give me 5. Make note of this up here so make sure you understand what I'm saying. The square root of 25 is equal to 5 because 5 times 5 equals 25. So when I take the square root of that number, it comes out. But when I try to take the square root of 2, it doesn't come out evenly. It's going to come out as a decimal. So I'm going to leave that as square root of 2. So 5 square root of 2 would be my answer. So when I come back here, I can write that as 5 square root of 2. So that is where you would leave that problem. So I'm going to go ahead and move on to doing example 2 with you. I'll clear ink and we'll do it on that page again. So now we have the square root of 28 is what we're going to try to work out. So this time we need to try to find a perfect square that is a factor of 28. Obviously 1 works. Can we divide 28 by 4 and it come out evenly? Checking your multiplication facts there, see if you remember. 28 divided by 4 is equal to 7. So that one actually works. So I can rewrite this as the square root of 4 times 7. All right, now we'll try to take the square root of each number. The square root of 4 will come out as a whole number. It will give us 2. If I try to take the square root of 7, that will give me a decimal. That will not come out evenly. So I'll just leave that as the square root of 7. So for my answer here, I'm going to write it down below. Give you a little bit of something to follow here, that way you see. I'll end up with 2 square root of 7. And that would be my answer. So bring that back over here. We have 2 square root of 7. So when we're doing this, the reason is because this is still technically an exact answer. We're not rounding in any way. If you were to take the square root of 50 or do 5 times the square root of 2, you'd get the same answer either way. you would get the same decimal answer from that, that's the only way we can do it exactly. Sorry guys, I have a cat climbing on me. Now I'm going to take us down to example 3. All right, so now we have the square root of 128. All right, let's take a look at that one. So we are trying to find the square root of 128. All right, so now we can go through the process once again. Obviously, I can divide it by 1. Let's see if I can divide 128 by 4. It works. Sorry guys, I was holding back a sneeze. All right, now, as I was saying, we can divide 128 by 4. That would give me the square root of 4 times 32. All right. Now, normally I would go to take the square root of each number from here. I would try to take the square root of 4. That's going to give me 2. Now, from here, I would try to take the square root of 32. But at this point, I want to point something out to you. I've made a mistake in this process. And the reason is because I did not divide 128 by the largest perfect square that it could be factored by. The reason I can recognize this is because 32 still has factors that you can divide out of it. So let me make sure I'm being clear here for you. In order for this process to be correct, you have to divide your number under the radical by its largest perfect square factor. So yes, 4 is a perfect square I was able to divide it by, but if I continue working the problem this way, I'm going to have 2 times the square root of 32. The reason this is an issue and not a correct answer, not a complete answer, is that 32 can also be divided by perfect squares. If you end up with a number underneath the radical or the root, if it can also be divided by another perfect square, you have to repeat the process. But if I would have just used the largest perfect square to begin with, there would be no need to repeat the process. So if I were to just continue, I would have to check 32 to see if it has any perfect squares that I can divide it by. And if you check, 4 would work, but also 16 would work. I can do 16 times 2. So my next step, I'm going to come down here and start another row. I'll have 2 times the square root of 16 times 2. Do you guys agree with me that 16 times 2 equals 32? That is how I chose to break this up and factor it out. Now, from here, I will try to take the square root of each number again. So this time I'm not going to write out the steps. I'm going to shortcut that. I have 2 times the square root of 16, which is 4. When you take multiple numbers out, they will multiply. Now I'll take the square root of 2. That does not come out evenly. So this will all be multiplied by the square root of 2. Here I can simplify this answer. I can do 2 times 4. That would give me 8 square root of 2. Now, that was a lot of work, right? Like a ton. A lot of steps, a lot of things to check. Now I'm going to show you what would have been the easiest way to work this problem from the beginning. So keep in mind, we're doing the square root of 128. So I'm trying to do the square root of 128. If I would have checked farther up my chart and not have stopped at 4, if I take 128 and I try to divide it by 4, we know that one works. By 9, that does not work. By 16, that one works as well. But I'm going to keep going. If I do 128 divided by 25, that does not work. 128 divided by 36, that does not work. 128 divided by 49, nope. 128 divided by 64. There we go. That one does work. 64 times 2 equals 128. So this is a way that I could factor the number. So I'm going to change this to the square root of 128 is equal to the square root of 64 times 2. Now we can try to take the square root of each number. The square root of 64 is 8 because 8 times 8 equals 64. So I'll have an 8 on the outside. And then if I try to take the square root of 2, that one's not going to work. And there's no perfect square that I can further divide it by, so I know the process is finished. So this time I got to my final answer in 3 steps instead of about 6 or 7 steps because I made sure to check each perfect square that I thought it could be divided by. Now, obviously, you don't have to check numbers that are higher than 128. You only need to check numbers below it. But that is how to simplify and make the process as quick as possible, is to make sure when you first begin that you are factoring your number under the radical by its largest perfect square factor. So that is the process. Over here we have 8 square root of 2. All right, I would like for you guys to try to do these others on your own. I will give you a bit of a hint. One of them is a perfect square under the radical. So whenever that happens, you can just take the square root of the number and write just a number by itself as the answer. Nothing fancy there. But then 3 of these you will have to go through the process on by dividing them by perfect squares. All right. If you guys have any questions, please feel free to ask. This is not a very easy concept for 8th graders typically. It's why I do it at the end of the year. So if you need further help on this page, please ask or ask me Friday during Zoom, okay? All right, you guys have a good rest of your day.